A very good afternoon, everyone. Welcome to INBIOSIS webinar lecture series number 3, 2023. Before I start, Prof. Dr. Syarul Nataqain, also the provisional moderator, is unavailable today, and therefore I am here as her substitute. I'm your moderator for today's session. My name is Nisha, and I'm a research fellow at INBIOSIS. Well, earlier just now, we have played a gist of our institute's background and research activities. For those of you who are interested to collaborate with us, feel free to browse INBIOSIS website and social media for the latest updates and information. Now, I'm very much excited to introduce our speaker today, Mr. Rezuwan Zakaria, who is from Nutrition Technology Sdn Berhad. So before I start, allow me to read to you his CV. Rezuwan earned his first degree and master's degree in industrial chemistry and chemistry respectively from University Putra, Malaysia. Currently, he serves as the Research and Development Manager in Biotechnology at Nutrition Technologies. Now, this is a multinational biotech firm and it has its headquarters located in Singapore. His industrial research interests include feed, scaling up microbial bioprocessing, biofortification for feed and industrial biowaste, as well as bioplastic from industrial biowaste and biofertilizers. Now, recently, the company Nutrition Technologies had launched a bioactive fertilizer, is also known as Tipsia, with a patented technology for soil and plant health. And it works very effectively against fungal pathogens such as Fusarium and also Ganoderma. And this technology has been a very huge breakthrough from his R&D division. With that, I welcome Encik Rezuwan to share his research experience here.
Thank you, Nisha. Let me know if you can hear me well.
Yeah, very clear.
Okay, great. Hi, everyone. I'm Rezuwan from Nutrition Technologies. We are a company basically breeding insects in vertical and mass size in terms of the size of the factory, of course. We are headquartered in Singapore and we have right now 3 facilities in Johor Bahru, and we are under the mode of expansion. We are very much in this insect industry. If you wonder what insect is all about in this industry, we are basically producing animal feed for pets and for husbandry animal as well, even for aquatic animals. And also we are producing fertilizer from these insects. I'll be sharing my slide right now. Okay, can you guys see this slide from your end?
Yeah, very visible. Can you maximize your slide? Yeah, okay, great.
Okay, great. Okay. I will try to use easy language as much as possible. I think delivering our science to the community, to consumer especially, is our prime target, so that once you guys understand, we can actually explore more on the R&D and how to fix the current agricultural practice to a better and sustainable one. I'm going to talk about the black soldier fly and the benefits, basically the huge benefit. That's why I use the term superpower over here. And from these insects, the black soldier fly itself, what would be the main benefits from the industry? Of course, as I mentioned previously, the first one is actually for animal feed. The insect protein, insect has a huge amount of protein and fat as well. They are very much well suited for animal feed. But the waste of this insects industry, since we are talking about the industry, right? So the factory, so we have huge amount of the insect waste. So this insect waste is purely organic. They are very much safe, and thus we convert them into what we call as biofertilizer. The word Frass over here refers to the insect waste. So in this industry, we call Frass, which refers to insect industries. But particularly in this session, I'm not going to talk the benefit of black soldier fly as an animal feed, but we are going to talk about the black soldier fly for as a fertilizer for to prevent plant diseases. Sorry. So talking about black soldier fly, if you wonder why we are working with black soldier fly, I myself is a chemist, and why do chemists is actually in this industry? And first I'm going to talk why black soldier fly. So of course we know cockroach, we know a lot of other type of insects. The scariest one, the one which is we don't like to see, we don't want to hear about, but black soldier fly is a non-pest. So basically they don't cause any harm effect to the animal, even to us. They are saprotrophic, meaning they evolve to eat, they decompose to eat organic material. As of now, black soldier fly has been reported to only decompose organic matter. So I don't know, maybe in the next 5 to 10 years, another insect scientist will come up with new finding. They will also degrade another type of matter. But for now, we are going to concentrate on black soldier fly ability to decompose organic material. For your information, we have a huge amount of waste outside there. They have been decomposed in various methods, ones with chemical method, high temperature methods. A more natural one is actually using microbial methods. But we have a natural, the Mother Nature's gift, which is black soldier fly, able to degrade those rubbish, those waste into safe organic material. Uh, Basically, these insects, they have a remarkable immune systems. They are able to produce up to over here 50 plus antimicrobial peptides. We are in a very active stage of studying antimicrobial peptides of black soldier fly. To my knowledge, there are 12 of the peptides has been studied in vitro in the lab, and there are the remaining of around 68 more has been identified through in silico study of the antimicrobial peptide. So I can say quite a more numbers of the antimicrobial peptide are being identified, and active studies on this are being conducted all over the world, including in our lab in Singapore and also in Johor Bahru. Due to the nature of the black soldier fly, they have been living with fungi. They live side by side together. If you wonder why I pick fungi, because other than insects' ability to decompose organic matter, fungi is the another guy in our ecosystem in which they are able to also degrade organic material. So black soldier fly has been living side by side with fungi. They fight, they live together, they consume the similar materials over a period of 40 million years. So they have evolved very much comfortably up to the level that they have developed, meaning these tiny guys, the black soldier fly, they develop their own biological weapons against fungi because they want to live comfortably, they want to live happily, in which they also develop biological weapon which actually the antagonistic microbes. This is actually our finding from our very own laboratory. Okay, I need to. Okay, we have. I place here Frass, LC Frass, and Go Frass. Don't worry about that. That one is actually our internal term. For LC Frass, they are much more. The Frass from much more younger type of the black soldier fly. Go Frass is more matured one. So Frass, as I told you just now, Frass is actually the insect residual, the insect waste from this industry. So what does this Frass actually compose of in terms of microbial composition? So they have their total plate count is quite high, 10 to the power of 7 to 10 to the power of 10. I believe some of you are microbiologists and molecular biologists, even biology yourself, you can understand this very well. They have this phosphate solubilizing bacteria. One of them is actually phosphomonoesterase enzyme that being produced by this bacteria to actually degrade the components so that the accessibility and availability in the soil is high. They have also the nitrogen fixing bacteria, the siderophores. We're going to talk about the siderophores later on. They have the chitinase enzymes. They show some sort of a chitinolytic activity. They have a lipase producing bacteria and protease producing bacteria. All of these actually come from the Frass microbiome. So I'm going to talk more about them rather than the chemistry itself. So as I put over here, microbes, BSF Frass microbiome consists of the microbe that improve the soil fertility. Eventually, when you improve the soil fertility, eventually it will lead to the plant health, preventing the plant diseases, maybe up to the level of curing them. Okay, next. How do I take next? My slide is not moving just now. I'm sharing another one time. Okay. Yeah. Okay, this is another one. The next slide of mine is actually I'm going to talk about the mode of action of the black soldier fly Frass. How does actually this black soldier fly Frass affect the plant health and also the soil health as well? So at Nutrition Technologies, myself and the group of scientists of ourselves, we propose three mode of action for the fungal antagonism. The reason we are mentioning fungal antagonism over here because we are treating fungal pathogens, meaning the type of fungi that can affect the plants. Those they cause a numbers of plant diseases such as a Fusarium oxysporum or Fusarium wilt in banana plant. And another one is actually for Ganoderma boninens, which call as a fungal pathogen disease in oil palm. They call as a steam road disease. So we propose three type of mode of action to show how actually the insect Frass can affect the plant health itself and the soil fertility. The first one being chitin upregulation towards the plant defense and the effects of the antagonistic microbes and the role of the siderophores in the plant health itself. This is the first one in which it shows here the role of the chitin in the upregulations toward plants defense. The reasons chitin that exists over here, I need to mention that as an insect, they are an exoskeletal creature, meaning they don't have internal skeleton, right? They have their exoskeleton. So their body is made of this exoskeleton. So we call it as the outer shell of the black soldier fly, outer shell of the insects. This outer shell is called exuvia. So if we have entomologists over here, they understand the exuvia is actually the skin. Basically, it is the skin of the insects. The skin of the insect is composed of chitins. So this chitin basically is what we are if actually naturally in the Frass of the insects. So they exist there as it is. They are natural component of the Frass. And then the role of this chitin is actually basically in a layman language to stimulate the plant defense. One of them is actually by producing what we call as a phytoalexins. So there's a number of roles for phytoalexins. Among others is of course plant defense. They are also able to protect the plant against the bacterial pathogens and of course against the fungal pathogens. They are also able, chitin itself are also able to activate certain numbers of protein that responsible for the plant defense systems. This is the first one. The second one is actually through the bacterial antagonism. If you notice in my previous two slides, I wrote down the role of the Bacillus halotolerans. This bacteria has been actually isolated from the gut of the black soldier fly. We inoculate them in the lab and then we add them into the Frass to enhance the function of the Frass. And one of the role for this one of the role for this Bacillus halotolerant is actually to produce an enzyme that can cause the cell lysis towards the fungal pathogens. So when it comes to cell lysis of the fungal pathogen, this leads to the fungi itself. I mean, it inhibit or killing the fungi itself. This is the first one. Second one is actually competition of resources among the fungi and also the bacteria. Both of them, they are consuming ferrum 3 plus iron over here. So they are consuming these two. So competition in resources in terms of space and nutrients, this has been by the role of this Bacillus halotolerant has made some sort of uncomfortability of these fungi. So they become starved. So their some of their biochemical reaction cannot be actually run. So they are degraded. So they die. And the other part is actually the induction of the systemic response, another type of the plant response system, which has caused by the bacterial organism against the fungi itself. The third one, we are suggesting the role of the cytophores. Cytophores is actually a molecules produced by the plant itself, in which the cytophores molecules are able to chelate, meaning they can form a chemical bonding with metallic ions surrounding the plant itself. So by this ability, in this case, we will highlight the role of ferrum 3 plus ion. Why ferrum? Because ferrum needs by the plant. Ferrum also is actually needed by the fungal pathogen. So both of these bodies, the plant and the fungal pathogen, they need the ferrum 3 plus ion. But the Frass from the insects, they have the microbe, they have the bacteria that produce the cytophos molecule. Cytophos molecule will bind with the ferrum 3 plus ion. They are forming the organometallic and a complex compounds. This complex compound has a very good role in promoting plant growth, plant defense in high drought environment, very dry environment and saline environment as well. So the role of cytophores here is actually protecting the plant and also promoting the plant. So these cytophores being produced by the microbes in the insect frass. So that is why insect frass is very good in working with this kind of a material. So those are the hypotheses that we produce by group of our scientists internally, and these are the data that actually available in research papers. Since that as industry we don't publish a lot more papers, but don't get us wrong, we read a lot of research data from the academic. I would say we skim the data a lot. We keep ourselves updated from the academic literature. We learn a lot from the academic people, and these are the data. For example, we understand that the Frass of the BSF defends plants against fungal diseases. In this case, they are working with Rhizotania, Fusarium, and Phytium. Chitin and chitosan, I would say chitin only. From the BSF at Suvier, triggers the plant defense system. This is actually similar to the mode of action number 1 that we proposed earlier in this deck. And chitin is abundant, of course. Chitin again, they are the material that form the molecular formation of the insect skin. So they are basically everywhere in the Frass. The composition is very high. And they also have the high amount of the phosphorus solubilizing bacteria, and which they call it specifically this phosphorus solubilizing bacteria. They mention over here function is PMEase enzyme activity. This is actually a specialty type of enzyme, phosphomonoesterase enzyme. So the phosphorus solubilizing bacteria producing these phosphomonoesterase enzymes, in which this enzyme will later on will react with a complex of phosphorus compounds, break down them, then produce phosphorus ion, which is then making this phosphorus ion soluble in the soil environment and in the plant environment, making them more accessible and increasing the availability of the phosphorus in plant growth is actually very good. And BSF Frass also, from our experience, even from this paper, we combine the use of the BSF Frass as a fertilizer and also with the chemical fertilizer. These two give us the best performance. So over here, I'm saying that I am not promoting only using organic fertilizer 100%, but we are also encourage the use of the organic fertilizer and chemical fertilizer at one time. The reason being, the first stage in plantation, the first stage one, the first 1 or 3 months, they will need the high amount of NPK, nitrogen, phosphorus, and potassium. But organic fertilizer, usually they are slow release material. They have the amount of NPK, not so high, but they really steadily, they slow release those material. But plant requires a huge amount of this NPK. Commercial plant demands NPK quite high, but for a natural plant that is not a commodity plant, they are quite okay. So that's why we always suggest the combination of chemical fertilizer along with organic fertilizer, in this case BSF Frass, to combine together and then to be treated on soil and plant to support the NPK requirement and disease prevention. This is some of our trial, in vitro trial. In this one, we are testing the 2 types of the most virulent diseases in commodity crop. I want to focus on the Fusarium oxysporum, TR4. This is actually the most virulent strain of Fusarium. It has caused, I think, hundreds of million losses, hundred of USD in terms of million losses for banana industry. There's a special name for banana disease. They call Panama disease. You can Google them to investigate about this disease. Thousands of acreage has been in loss, and of course in terms of profit loss as well. For this one, Ganoderma boninens, for Malaysia and Indonesia, they are very close to us. As you can see over here, what I can show the role of the BSF Frass, Bacillus halotolerans, and Diptea. For your information, Diptea is our specially formulated product. We combine the Frass, the insect Frass, and then Bacillus halotolerans, and we added with extra skin of the insects, meaning in addition to the abundance amount of the skin of the insects in the Frass, we collect some other amounts of the insect skin as well, which is still bacterial insect. We add them into our formulation, and we call them Diptea. They have been launched a few weeks ago in Kuala Lumpur and Selangor, and we have been receiving a lot of demand for Diptea at this moment. a new factory being set up in Silong, Johor as well, to only produce the diptyr and maybe the sister of the product later on. As you can see over here, diptyr can inhibit the growth of the virulent TR4 up to 90% and up to 82% for Ganoderma boninens. This is quite high. In fact, that's why I call it as a superpower of black soldier fly. They can inhibit a very high inhibitory percentage. Usually 60 to 73% is considered as highly antagonistic, but more than 73% is very high, but we have here up to 90%. And I will show you later on, one of our external party from UPM indicated the diptyr inhibit more than 90% for the plant disease study. This is the tomato trial, the one conducted internally by ourselves. We have a lot of farmers in our factories. Except me, I'm not a farmer anyway. So you can see over here, in this study, we combine the diptyr and our chemical fertilizers I call NPK. As you can see, you look at the root picture over here, diptyr and the NPK. NPK stand for nitrogen, phosphorus, and potassium, chemical fertilizer anyway. Combining them two, they give a very good root length, thus plant growth and the root mass of it. That's why previously, even from one other paper, we also mentioned that the combination of this organic fertilizer and chemical fertilizer are best for plant. This is another tomato trial as well, conducted internally by us. We can see that the treatment without the diptyr has the highest disease incidence. Yeah. These show that diptyr is very much needed in preventing those diseases. This is conducted by our UTM partner on the Brassica field trial. The data is actually very much interesting. As you can see over here, we found that they are not using diptyr during this moment. They are just using our composted Frass. From the fresh Frass, what we do is actually 90 days process of composting, making them more safer for the soil and for the plant. And you can find over here the first graph, the chemical fertilizer brand, and the chemical fertilizer with diptyr give the highest amount in terms of the average plant weight, and quite comparative in terms of the average root length as well to other treatments. In terms of the soil total aerobic plate count, okay, for I saw there's another one of our participants is actually from Pusat Tuition. This is interesting. Okay, for non-science students, what I can say is actually the diptyr, the use of the insect Frass, they are very good in terms of enriching the contents of the Frass, the contents of the soil itself. Meaning, soil don't just need chemicals. They don't just need fibers. They don't just need sands. They also need microbes. Living organism must be in the soil so that the plants can live very well. The soil can become fertile. So in our study over here, we have indicated that diptyr increase the amount of the microbes in the soil. But then again, I always say that we do not want you to only use the organic fertilizer at one time. We want you to use the chemical fertilizer and also with the diptyr, with the organic fertilizer. If you are only using chemical fertilizer, from this study you can see total aerobic plate count over here. They are very much super less. So this is not good for the soil fertility. And the use of diptyr as well increase the soil organic matter. This is also very important component in farming. For oil palm, this is another trial conducted by UTM. It indicated that the use of the diptyr via top dressing application increase the plant height actually. We are going to conduct another external trial with UPM, hopefully with Professor Wong later on. We are going to test against our diptera with oil palm against the Ganoderma boninus. The reason we are conducting so many third-party external trials because we have very active internal trials. We have a lot of scientists doing it, but doing or being in this industry, we want also other party, which is not us, which is not interfered by us, to also conduct the same trial without us, so that we can see whether the way we are conducting our trial and the way the third party is conducting trial are actually comparative, and the result is actually useful for the farmers, for the industries. This data, this is quite interesting. This data is actually provided by Associate Professor Dr. Norbaiti from Faculty of Biotech, UPM. Quite recent data, a few weeks ago, and she started the trial early of the year, and we come up with a view of multiple of treatments over here, as you can see in the list of treatment, and we found that T2, as you can see over here, we put high amount of diptera and low amount of Fortis. For your information, Fortis is the sister product of diptera. Diptera in solid form, while Fortis is actually in liquid form. So we combined our diptera and Fortis. We introduced to the banana plant in Dr. Norbaiti's trial. And in T2, as you can see, they give the highest amount of resistance. The disease index of in T2, the disease index percentage is 4.17. From my understanding, disease index 4.17 is among the lowest I have seen compared to other biological fungicide. If you look at T4, this is actually the chemical fungicide. The disease incidence, of course, it is 0. This is actually very, very good. Of course, 0 incidence of the disease. But by using organic fertilizer, which is way more safer, the disease index is only 4.17, indicating that the diptera, the organic fertilizer from BSF, can inhibit, can prevent this disease up to 96%. I think this is the highest an organic fertilizer has shown so far. Okay, I have a lot of work cited over here. I believe I've actually used a lot more, but this is some that I can show over here. Yep, I guess that is all from my end. And if you want to know more information, yeah, I like this packaging anyway, although it is not the one that I designed. You can actually scan the QR code, and then you can read a lot about them. You can ask questions as well. Thank you very much.
Ada satu. Ada dua. Oh,
Over to INBIOSIS.
okay, thank you very much, Rezuwan, for such an interesting delivery just now. We have questions coming in, but before that, let me throw you a question first. So I understand the product development here is actually a consortia of bacteria and microbes, which are being isolated from an insects, right? I just want to know the efficacy of this microbiome to establish themselves in a new soil condition, because they are, the origin is from insects, and then now you are trying to establish this population in soil. So my question is, how when you establish them in the soil condition, what is the colonization like? How long you get to see this microbiome? Do they die off very fast, or you can see the population throughout the plant growth?
Yeah, one of the study by UTM, when they check on the total plate count of the soil after the application, they are quite promising. But in relation between the Frass microbiome and the soil microbiome before and after application, we have not done so. It is ongoing. I myself, I would like to explore that as well for sure. But I would say that I can tell you that this insect is actually consuming oil palm waste. And very much the oil palm waste right now being reused as a fertilizer, right? So
Yes.
we are using this oil palm waste, but not to directly put them into the soil. What we do is actually we are using the oil palm waste and then we are feeding the insects. And with the combination of the insect microbiome with the oil palm waste microbiome combined together, then we are putting back this oil palm waste with the insect waste together into the soil. I think they are way safer and much safer. But I agree with you, the efficacy is, I mean, in terms of microbiome efficacy, is a study that much needed, especially for us to understand better. Thank you, Nisha, for
Yeah,
that.
moreover, because we are subjected to a very challenging environment, sometimes
True,
the
very
climate
true.
change, a lot of factors can actually disturb when we want to try to establish this type of microbiome. Okay,
Correct.
so I would like to, we have one question from Atira Eliana. Her question is, if she wants to know if chitin is considered as antimicrobial peptide and is laying eggs are
Mm.
seasonal in BSF.
I
Chitin
will
is
go for
not
this.
an antimicrobial
Correct.
peptide, certainly.
Correct.
Yeah,
Correct.
then
Yeah.
the rest is for you.
The second question, Nisha. What is the
Laying
second question?
eggs, a
Uh-huh.
BSF lays eggs seasonally? That is a question. Does
I'm not the
BSF lay eggs seasonally?
we have
Seasonal
a system
switching?
in Yeah, we have a system in our factory that controls the laying eggs mechanisms. Not in the Frass, of course, but I'm not the right person to answer that. I'm not the entomologist, but I can say that in the industrial setting, we control their rearing stage, their laying egg stage, so they are pretty much safer. They have each stage engineering and by engineering control from one stage to another. Yeah, but I agree with you that Nisha, chitin is not a peptide. This is another form. I don't know how to say this. It's a it's a molecular formation of the insect skin itself. If you study fungals, they also have chitin surrounding the body of the fungal itself. So when you have chitins, you for sure you will have chitinase, right? Endogenously. So this chitinase will act against the fungus as well, and to break down the fungal cell wall, which eventually lead to the cell lysis of the fungus. Some of the basic understanding about the chitin, and then chitinase. Some, of course, will lead to chitosans, but chitin to chitosans biologically is quite difficult. There is some studies on that, of course.
Yeah, thank you. So the next question is from Dr. Murni. So she's referring to your results just now, because you were showing two types of results. So the first case, you had a treatment, chemical fertilizer in combination with dipsha. And
Mm.
the second case, you had organic fertilizer in combination with dipsha. So she
Mm.
wants to know why the first combination has a better result than the second combination.
Is this the one,
Um,
Dr. Murni?
no, we cannot see your slide.
Oh,
It is stagnant
okay.
at the last slide.
Okay, okay. Okay, well, let me check from here.
I think the one
We
with
do
NPK.
the one
Yeah,
with
the
the
slide
NPK,
with
right?
NPK. Yeah, I think it's
Okay.
for the bok choy.
Yeah, I can see it from here.
Mm.
Uh, we have numbers of study that we combine NPK, chemical fertilizer, with DPTR, and then we also compare with chemical fertilizer with another organic fertilizer. But to answer Dr. Moni's questions, there could be other organic fertilizer combined with Diptia, they give better results, or organic fertilizer combined with chemical fertilizer will also give results. Most of the time, I would say the presence of the NPK. The higher the NPK, the better the growth of the plant itself. They'll be much more faster. Okay, for industrial farmers, for example, they don't want to wait. Once they start using the fertilizer, if it is actually 6 months duration, they want everything to be in 6 months stage. They do not want to become an organic farmer. Organic farmer can wait from 6 months, maybe they can wait for 8 months, right? They can wait for the yield, they can wait for the growth, but not for industrial farmer. So this is why we combine chemical fertilizer with organic fertilizer. But if you're asking me why another organic fertilizer perform better compared to Diptia, this is something that I try to avoid to answer. But I think the composition of that organic fertilizer. In our case, our organic fertilizer, the Diptia itself, they are promoting plant disease prevention. This is what actually we want the narrative to be. You know, they are preventing the plant diseases. There are some of the component is for plant growth, but I would say the very much content and the narrative of the data is actually for plant prevention rather than the plant growth itself. We are still working on how actually we can support the plant growth. Maybe the combination of the DTA and other organic substances. Yeah.
Okay. Dr. Murni has another question. So she's very interested to know about the treatment combination. She's asking, why do you use two different types of Dipsha and Fortis?
Okay. Fortis is actually our sister product of Diptia. They are in liquid form, and Fortis is actually designed as a foliar. Not as a actually soil treatment. They are designed as a foliar. For Diptia, this is actually for soil. We can apply directly onto the soil. So there is a multiple mechanism for the application of the Diptia. But for Fortis, they are meant for foliar application. So that is the two main differences between the two. Diptia, we have launched very superb results. For Fortis, they are at the final stage of the R&D. I can say we have actually reached up to 95% of the Fortis. Fortis making is actually quite complex. They requires the Frass itself to be turned into liquid, and then this liquid need to be stabilized through multiple fermentation processes prior to bottling, and then apply it onto the plant. So the one is actually the basic Diptia fertilizer. The other one is actually foliar application.
Okay, that's very clear. Okay, we have an interesting participant. His name is Petani. Maybe it's a she also. I hope I'm guessing it correctly. He or she has got a very relevant question. The question is, can the BSF Frass help to regulate soil pH, thus make the soil more fertile? In this case, there's no need for calcium carbonate. Is there any sign to indicate over-fertilizing on crop? I think has got two questions. Can BSF Frass replace calcium carbonate is the first question. The second question is, if the application of BSF Frass can show any sign of over-fertilization.
Okay, I will go to the second question first. Can the use of BSF Frass be in overuse? I mean, over-applying. We have tried that in Simpang Renggam. In one of the trial plot, we try the minimum amount. Another trial plot, we try the calculated amount, meaning optimal amount. Another trial plot, we try the maximum amount, meaning we put the most we can. What we found is actually there's no such thing of oversupply of the BSF Frass into the soil or to the plant. But the thing is, organic fertilizer is not cheap, right? So the trick or the reason, the thing that will stop you from overuse of your organic fertilizer including BSF Frass, is actually not the BSF Frass itself, but the cost of producing the BSF Frass, right? That will be the limiting factor. Okay, about the pH, as far as our research, we have seen that the pH of our Frass is actually quite neutral, meaning they will not very much change the pH of other thing. The consortium of the microbe tend to become like they try to stabilize the pH within themselves. So in terms of replacing BSF Frass with calcium carbonate, I don't think that is a good idea. One of our finding in one of our trials somewhere in Kulai, we tested this farmer is using calcium carbonate. We found out that by using too much of the calcium carbonate, the soil become rocky, crust, crust. Then we come and then we apply the BSF Frass. So when we come and apply the BSF Frass, the soil become more porous, and then the plants start to grow because the root can grow much more better. They have high accessibility towards the water and so on. So in terms of the pH, I don't think very much, but in terms of the porosity, yes. So we want to avoid a very rocky soil in farming practice anyway.
Mhm. So it improves the soil texture. Yeah.
Yes, very much.
Okay.
Why?
Okay, that's very
Well,
clear.
yeah, the nutrients in the Frass itself, and the Frass is actually very fibrous. They can absorb a lot amount of water, meaning they can contain the water for a longer period of time. They degrade slowly in the soil, so meaning they release their nutrients slowly. So if you apply too much of the chemical fertilizer, for sure they will be leaching over there, right? So oversupply of chemical fertilizer lead to leaching, but oversupply of organic fertilizer does not lead to leaching, but the limiting factor is the cost of the organic supply, which I don't think I will overuse the organic fertilizer.
Yeah, very true. Okay,
Yeah.
next, maybe we can attend the next question is from Encik Johan. He wants to know if there are differences in terms of the microbiome composition. He's comparing between BSFL and feed insects like mealworm.
For sure. For sure. Right. If you compare microbiome composition, different part of the BSF, it be different. Different type of insects, for sure, it be different. I do not know about the microbiome of the mealworm. I don't have any idea. I never see an example of them. But from my study, the microbiome of BSF will change from one type of feed to another, will change from one stage of process to another stage. So we have studied this microbiome transition from stage 1, stage 2, stage 3. The microbiome in the gut, the microbiome on the skin, the microbiome of the waste are varied. So to answer that, yes, they have huge differences. Mr. Johan, right? If I'm not mistaken.
Okay, next question is from class tuition EYO Rawang. So the
Okay.
question is, what are the main challenges in breeding and also processing BSF at your facility?
Right now is the temperature. Super hot temperature, right? Well, yes, weather is the one of the challenge that we are facing. Another one, you are dealing with insects. Can you imagine having millions of cockroach in your room? What would that be, right? So the smells, the smell is not like the smells that you like. So the smell is another thing. Another challenge is actually the manpower. Okay, to hire a good talent in this industry is also difficult. To retain them is another thing, and another technical or engineering problem. I think we can endure it. We can face it quite comfortable. In terms of the supply of the black soldier fly, we are very good. We have our own bank to conserve our eggs to conserve our inoculants. Yeah, I think that is very much climate. Yeah, and of course regulatory. If you know that in Malaysia there's no such thing of insect regulations, right? So to sell or cannot sell, or when to sell or how to sell, there's no such thing. So the government still in the process of finalizing or enabling this industry. So what we are doing or what we are facing right now, if you have trouble in terms of regulation or policy, we always refer to the European society and US to understand better on how to adapt the new regulation into this industry. Yeah, that is the thing.
Okay. There's another question from Johan again. So the question is, does substrate or waste food given to the BSF larvae affect the microbiome or the composition of the microbiome?
I don't understand the questions.
He's asking the waste food that you use to feed the BSF larvae in your facility, the food that you give, does
Okay.
that affect the microbiome of the larvae itself?
Of course, of course. For example, if I choose my, we call it as a feed, right? The food for this animal, we call it as a feed. Let's say if I choose oil palm waste as my feed for the black soldier fly, and another round I will choose, let's say I choose pineapple waste as my feed for black soldier fly, and another trial I will choose, let's say tapioca waste. So I will have a different type of microbiome. For sure, and for certain, you will see a different chemical composition of the waste. You will see a different composition of the insect protein, and for certain, you will see a different microbiome. But that is very much academic. We have seen that. We have run multiple type of microbiome study using different type of waste, agriculture waste, and different type of treatment as well. Yes, it will impact your microbiome for sure.
Okay, there's another one more question from UPM. We have Azrul Afiq. The question says, does your company provide any training on cultivation or farming of BSFL to the general public? And he wants to know, how can he contact you?
Okay. No, as far as I concern, no, we don't provide training to the public, not to the farmer. We are very much focused on what we are doing, but you can, I think in my last slide, I put my contact numbers over there. Do you see that?
No.
At the bottom there, at the bottom of the QR code.
Maybe you can post. Now, yeah, we can see it.
Yeah.
Yes, we can see it.
Yeah, you can text me if you want. I'm a slow reply for WhatsApp, but what the heck? Just text me, if you have any questions, why not? We don't provide that kind of training, but we do offer internship for students from universities, local and international. We also work collaboratively with numbers of university, UPM, UKM, USM, UTM, NUS, and even in Indonesia, in Vietnam, in European countries as well. We welcome collaboration from industries as well to work together with us. Yeah.
Okay, there's another one more question. This is an opinion question for you. The question says, what are your thoughts about our national agricultural system? Are we going to witness a risk of unfertile soil in the next 30 years to come? It is actually posed for agricultural system as a whole. And please comment on the soil fertility.
Yeah, as I said just now, if we are using continuously only chemical fertilizer, if we practice only chemical fertilizer in every part and corner of our plantation area, there will be too much chemical inside, they become rocky, the soil will become infertile. That's why smart farmers, what they are doing, they will use a combination of chemical fertilizer and organic fertilizer. I will not blame farmers not to use organic fertilizer. You must understand they are in the profit generation company. They must gain profit for them to survive. So they cannot get rid of the chemical fertilizer. But these responsible farmers, they know what worse will come if they continuously use the chemical fertilizer. So they combine with organic fertilizer. The challenge is actually the price of the organic fertilizer and the price of the chemical fertilizers. So they need to balance, they need to compromise a little bit in terms of cost. In terms of the soil infertility, I would say it has been more than 100 years. We have been using only chemical fertilizers. And in many parts of the world, you can see that the plant become less, less productive because they are quite used to only certain type of chemical. And this type of chemical has been increased over a period of time. So they give so much hazard to the soil and of course to the plant. How are we going to do it? So in our part, in our company, what we can do is actually we are now offering a better option for these farmers for their soil fertility concerns. So I think very much company outside there, they are trying to offer a more sustainable options for these farmers, for the agricultural industry to adopt a new innovation and technologies. But again, it is up to the maybe another stakeholders to set a record high. How would the farmers and the entire nation would like to set their soil fertility status? I think this belong to the government to answer that questions, certainly.
Yeah, good answer. Another one more question we have from Siti Noor Fadlina. Is there a specific time during plant growth for application of this fertilizer? Do you have a specific time for fertilizers application so that you will be able to maximize the plant growth?
Okay.
And if so,
if you are looking for, yeah, continue, Nisha.
If so, how it differs from plant to plant?
Okay, correct. Yes, this is very good questions. There is certain time or stage at which you can apply the organic fertilizer and then later on you will apply chemical fertilizer. Let's say I'm going to talk about Ganoderma disease in oil palm, right? Ganoderma disease in oil palm, they are caused by fungal pathogen, Ganoderma boninus. They are very much caused by the soil. Fusarium is also caused by the soils. So if you do your plant seedling, you plant your seedling onto the disease contained soils, you will not be able to stop the disease already because they are there. They are already in the soils. So best to actually apply Diptia is before you do the planting of the banana and oil palm. I recommend at least 1 or 3 months earlier so that this Diptia will then inoculate your entire soils and then it will actually get rid of the fungal pathogens. But in terms of the plant growth, since that Diptia and other organic fertilizer, they are not a fast release NPK type of fertilizer. You can apply them at the beginning and then maybe every 1 month, and then some of the farmer apply every 2 months. I think that will do for now. Again, we are not actually talking about plant growth over here. We are more talking about preventing plant diseases at this point of time.
Yeah. Okay. Another one more question. I think this would be the last question. BSF oil. BSF oil can be extracted from adult BSF or only from the larvae?
We prefer to extract them from the larvae stage because of the safety concern, and they also have a high amount of the insect oil. And for your information, right now we are using the insect oil, the black soldier fly oil, for making macro, micro, and nano emulsion, which we are very much anticipated to try our insect oil emulsion as a foliar product in the future. Yes.
Oh, so we have a number of questions. So I've been told that I have to attend all the questions. So you are
Okay.
yet to rest yet, okay? So never mind, we will extend a little bit longer. And okay, I will continue. Next question is from Farid Sairi. So he wants to know the effect of combining the products. Because when you use your product in combination, the efficacy of the treatment becomes greater. So is it possible to increase efficiency? The results that is being observed, increased efficacy is attributed by the microbiome or is due to the nutrient added?
Well, I would say the combination of those two, the microbiome and the nutrient adders. So this will impact your plant growth and your soil fertility for sure. Combination wise, I've seen this in our farmers trial, our own internal trial, and our own the other external trial. Combination of organic fertilizer, DTA, and chemical always good for most of the crops.
Okay, so
Yeah.
there are a lot of questions coming in. So some of the questions you have already answered, yeah? Yes, temperature did influence the egg laying process. I think you have already mentioned, so I'm not going
Yeah.
to pick on this question. The next one is from Farid Sairi. Will you be interested to combine different types of microbes in the product from our local strain?
Oh, of course, of course. That would be my vital role in the R&D actually. We call it as a cocktails of microbe, serve better than the individual microbe. But then again, you need a very good microbiologist to tell me which microbe is good. And we in nutrition technologies, we are not simply choosing any microbe. We prefer this microbe from the BSA itself. So meaning we do not want to take other foreign microbes and then combine the BSF microbe. I think I will need to do another efficacy study to see whether they can get along together or not. So that is why most of our microbe come from the BSF itself. That will be better.
Okay. Then next we have a very big question from Haris Nasir. He wants to know the anti-phytopathogenicity mechanism of Diptia. But I think you already explained
Yeah,
this in your slide. You know, it's all the science, the cytopore and everything.
yeah.
But I think you'll be able to attend this. The second question is, how practical is this product to be used in field? I think this one is more suitable for you.
Okay, how practical are they? For me, it is quite practical because, we have started this R&D trial since 1 year ago, and now we have completed the R&D trial, meaning lab scale trial have been completed. We also run external trial led by UPM, two by UPM, and also one more external trial by one university in Indonesia. So in terms of the field trial, in terms of the readiness of the product for the industry, they are ready. There's some orders are actually coming already. The factory has been set up. So they are very much ready for the field application.
Okay, next we have a question from Azrul Afiq. He's from UPM. So he's very much interested on the cost of production for your product. Okay, 1 kg of BSFL, taking into account environmental factor, maturity, and the amount of time taken to reach the larval stage.
As always, in other industries, not just in insect industry, cost of production will be very much confidential, something that I cannot reveal.
Okay, yes, understood.
Yeah.
Okay, next one. Again, we have question from. We have 3 different questions from Patani. Which one is better to dry out the BSF larvae using microwave oven or dehydrator? These two
It
methods
depends
going
on,
to affect the nutrient on the larvae.
well, in industry, we always try to find a method that is cheap enough, because the cost of production is high. So in terms of which method to be used, I would say, I mean, for me, best is actually slow drying method. Why? Because slow drying method will depending on what temperature you are working on. For example, if you are working on 40 to 50 centigrade, it be good for your peptides. You can preserve your peptides, not the enzymes. Maybe some microbe will not be available after that. But what actually you are looking from those larvae? Are you looking for protein? Are you looking for the fat? Are you looking for other components? It depends. The process of heating them depends on what you want. But I always prefer a slow heating. But believe me, even my production will disagree with me because slow heating is not productive. They are not generating a lot of money. Yeah.
Again, he wants to know on the production side. He wants to know if grinding the dried BSF larvae, does it becomes oily?
Hmm. Mm, depending on the level of drying that you are working on. If you are working on small batch, for example, I tried small batch and slow drying. There will be some amount of fat and you will see some stickiness, oily feeling on your paste. But if you freeze dry them or you really heat them at very high temperature up to 120 degrees, I mean, the majority of the fat will be gone. So the paste will be less sticky, less oily. But there will be certain amount of fat deposited in that fraction for sure.
Mm-hmm. The third question is he wants to hear your personal opinion on overfishing. And do you think we should substitute BSF as a protein intake? If I understand this question correctly, I think it is for human.
Okay.
It's asking us,
Oh,
shall we consume BSF instead of fish?
I myself, I never tried any single pieces of BSF protein, even from the factory or even from the lab, even if they wash with ethanol. I don't recommend, I don't recommend BSF in Malaysia and in Southeast Asia. We produce them for the animal feed purpose, not for human consumption. Of course, there is a level of microbial safety that we need to look into. So I do recommend for human consumption. It always meant for animal feed only.
Mm-hmm. Okay. Okay. Next question is I really like this question. It is from Haris Nasir. So he's saying regarding the oil palm trial experiment that you showed just now. So is the palm height, since palm height is only a vegetative measurement, it's asking if
Correct.
you are considering the trial and what is the amount of the product that was applied for a 6-month year old oil palm seedling trial, and if is there any trial provided for unmatured and matured oil palm trees? Because right now, for in the case study that you have tried, you only
Mhm.
worked on oil palm seedlings. So
Yeah,
he
yeah,
wants to
true.
know results on trees.
We do not have that data yet. That is why I mentioned to you just now that we are going to have another trial with external parties, hopefully with UPM, to go on the oil palm. We must remember oil palm trial takes a lot of time. You know, the best is actually 3 to 5 years, and not many industry, not many partners, I would say, would love to stay with us for 3 to 5 years. I don't think so. That is why for oil palm, what we are working on is actually at the seedling stage. So we are very much welcome if there is some outside there, if there is a partner who can be very patient enough to stay up to 3 to 5 years, please, I'll be very happy to conduct the trial on site myself.
Yeah, maybe we can target the independent smallholders.
Yeah, true,
So
true,
yeah, try,
true.
yeah. Next one again from Atira Eliana. Yeah, just now the feed will affect the microbiome. Now the same question, if the different type of feed will affect the growth of BSF or not.
Yes, for sure. we have a special division monitoring on what type of feed to be fed to this BSF. So they are using a statistical data and software, and we use our internal data. We are testing numbers of type of different vegetable, different type of agriculture waste. So we know, if let's say we want our product to have high protein, we know what type of feed we can use. If we want our feed, our BSF to have high amount of insect oil, then we know what type of feed. So certainly we have computed, and it is a patented technology, what type of feed will actually link to what type of frass, what type of insect protein that we want. If you want high protein or low protein, we can do that in our factory.
Yeah,
Nisha, I saw another one question which is quite interesting. Do your frass smell? Okay.
yeah, it's from the same person.
Yeah.
Yeah.
Yes. The smell is actually like earthy smells. Like macam bau tanah. Depending on the feed. Let's say if I feed my black soldier fly with huge amount of the coffee waste, so my frass will smells like a coffee. So it depending on the type of feed, right? If you feed them with a very smelly agricultural waste, then you will see the entire factory will smell super smelly. So the smells is actually determined by the type of the feed you fed into the BSF. But due to our IP, we can control these smells by controlling what type of feed to be fed to the BSF.
She also wants to know if you're exporting your product.
Oh yes, we have started exporting for the protein and for the frass as well. So we have just got the approval from the EU. So we are exporting. The first one is actually protein, and we are in the midst of asking for another permit approval from the EU and from the other part of the region for the BSF frass as well.
I think that's all. I have attended all the questions. With that, we have come to the end of our webinar. The audience size today is 86. You have 56 participants on WebEx and another 30 on FB. Okay, so I would like to thank you again for your time and sharing all the in and out of your product. And it was such a thoughtful sharing. Before we end, I like to invite all our participants to share your video so that we can take a photo. Okay, and our technical team will assist with the photography. I'll pass it to Wan Intan.
Hi participants, kindly switch on your camera for photography session. Alright, okay. Okay, smile. 1, 2, 3. Okay, another one. 1, 2, 3. Alright, thank you.
Thank you, everyone.
Yeah, thank you very much. So before I end, there's some housekeeping announcement. So all participants, don't leave yet. We will produce a link for your attendance and you'll be earning a certificate. All right. So with that, I would like to thank you again, Rezuwan, for the wonderful sharing. Take care and see you again on our next webinar.